In this video, we will learn how to find out the growth rate of output given the Cobb Douglas production function. The question is, suppose the aggregate output is given by y is equal to a times k raised power alpha times l raised power beta, where a is the productivity parameter and sum of elasticities of output with respect to capital and labor is 1. If capital and labor each grow by 7% and productivity grows by 3% in a year, the growth in the output is, we need to find out. The options are being given, we need to find out the correct option. So okay, what we are being given? We are being given a Cobb Douglas production function, that is output is a function of a, which denotes the productivity parameter, okay, that very growth which is not explained by capital and labor, which are the inputs, times k denotes the units of capital employed, raised power alpha denotes the output elasticity of capital, okay, the share of the capital in total product in the total productivity growth, times l raised power beta, and this also denotes the output elasticity of labor, okay, how much output increases when there is change in the labor by 1 unit, that is being depicted by this beta, okay. Given this Cobb Douglas production function, what we are being told? We are being told if sum of elasticities of output with respect to capital and labor is equal to 1, that is the sum of output elasticity of capital is alpha, output elasticity of labor is beta, it is sum is equal to 1, that is being given us. Also we are being told that capital and labor grows by 7%. Let us denote growth rate of capital by, let us denote it by k star. It is being given 7%, and growth rate of labor, let's denote it by L dash, okay, or L dot, which is also being given as a 7%, and growth rate of productivity parameter, that is being shown by 3%, let's denote it by A dot, it is being given as 3%. We have to find out the growth rate in the output, okay. Y dot is what percent, okay. So how do we solve this? First thing is, we change the given production function into logarithmic form, okay. So changing it into the logarithmic form means, let us take log on both sides. So can I write log of y is equal to log of a plus alpha times log of k plus beta times log of L, okay, using the law of the logarithms, that is if we have, what I can say, if y is equal to, let us say x w p, its log is log of y will be equal to log of x w p, which can be written as log of x plus log of w plus log of p, okay, from the law of the logarithm. You know it very pretty well, I don't need to explain it further here. And also we know that if we have a raised power x, its log is being given us as x becomes coefficient to x log a, okay, x log a. So I will not go into the further details. Then what we need to find out, let us, rather what we need to do, differentiate, take the differentials both on both sides, okay, differentiate both sides with respect to given parameters. So derivative of y, let's denote it by, we know derivative of log of y is equal to 1 upon y times del y. Similarly, log of a will be 1 upon a times del a plus alpha log of k is 1 upon k times del k plus we have beta, the derivative of log L, we know it is 1 upon L times del L, okay. Simple thing, if we have log of x, its derivative is 1 upon x dx, okay. Rewriting it again, so we have del y upon y is equal to del a upon A plus alpha times del K upon K plus beta times del L upon L. Now what is del Y upon Y? That is change in the output divided by initial output. This denotes the growth of the growth rate of output. Let's denote it by Y dot is equal to del A upon A, that means the growth rate of productivity parameter, plus alpha times del K upon K means the growth rate of capital. Let's denote it by K dot plus we have beta del L upon L means L dot. Okay. What we are being given, K dot is equal to 7%, L dot is equal to 7%, A is equal to 3%. Can I write growth rate of output will be equal to A is being given us as 3% plus alpha times K is 7% plus beta times L is also 7%. That implies, if I write it here, Y dot will be equal to 3% plus, let's take 7% common here, 7% common, we are left with alpha plus beta. So growth rate of output will be equal to 3% plus 7%. We know that sum of output elasticity of labor and capital is equal to 1. Alpha plus beta is equal to 1. That gives us growth rate of output will be equal to 3% plus 7%, which comes out to be 10%. Okay. So what does this 3% tell us? It shows us the change, rather the growth rate of output, which is not being explained by the factor capital and labor, which denotes the state of technology. We also call this shallow residual. Shallow, or we also call it total factor productivity. Okay. And it shows us the change in the growth rate of output, which is not being explained by the inputs here. I hope I make myself clear in this video and you find out this video helpful. Thank you.